This is an original copy of Wizard's Crown for the Commodore 64. I bought it recently for $100 shipped from the US, so with extra customs duties I don't want to talk about. This game was published in 1985, so about 41 years ago. It was released on several platforms such as Apple II, Atari 8-bit, Atari ST, MS-DOS, and as you can see, also on the Commodore 64. As part of the Too Many Hours series, I decided to play this game after finishing two other excellent games from SSI, Shard of Spring and Demon's Winter. So let's try to preserve this copy using the adapter and see if removing the protection will be as easy as with Shard of Spring, a video about which you can find on my channel. The adapter I am going to use is called XU1541. My previous OpenCBM installation was corrupted, but running the install.cmd from the OpenCBM directory reinstalled the required drivers for USB ports. Let me verify the communication with XU1541 by executing the cbm-ctrl detect. Everything's back to normal. Let's get to work. The first thing I will do is list the directory on side A of the disk. After more than 40 years, is there anything still on that floppy? Of course there is. I never doubt the reliability of the technology from that era. The file names aren't cryptic at all. In, party, encounters, town, and a monster. It takes 2 minutes 20 seconds to copy one side of a floppy disk, so I will save you the wait. What's on side B of the disk? Let's check. Oh, I see. A lot of dungeons and more dungeons. Let's also save them. Both sides are preserved. Let's see what's the content. So I have attached the final cartridge free, my trusty device for hacking. Let's try to see what has changed with this. When I do directory listing, I see something else. So as you see, this is the same kind of copy protection, let's say for listing, as it was used in Shard of Spring, the game I removed the copy protection before from, and then this one actually just stops listing the directory. So this is kind of a hack done just to prevent from seeing what are the files. But when I try to load the file from the disk, the first one, it loads it under location in hex 0801 to E83. Let's see the list. As you see, this is basic. Starts with the basic, and just from my experience, I can already, without even looking at this code really carefully, I can already tell that besides things like setting the screen to be black and displaying the name of the game, there is some very interesting if statement already, something which already pops out from the screen. And this one checks the area location at 40451. If this is different than 255, then it goes to line 7000. Let's see what is in the what's in the line 7000. Yeah, as you see, this is exactly the copy protection failure. So in this case we can call SSI to help us if needed, but I think I can sort it without their help. And that's also, this is go to 7040 line, so this actually is an infinite loop. So nothing more than that, nothing really fancy. So technically, looking at this code, probably if I disable just this last statement or more, then yeah, this game should work. But let's try to find out actually what's happening before that, because it looks like indeed this copy protection over here can be removed, this check, and the game will just progress in line 9 to read the pregame.o and then do some go soup 20,000, and there is some more things happening. So just let's check the first things. So first of all, starting from line 1, I see that poke 51 is used and 52. This is actually setting the pointer to the beginning of string variable after basic, and the pointer to the end of the basic is set here in within these two pokes 55 and 56. So that's set. Also the comment says it already, change high mem for basic. Then we have this poke 924,0. Actually I don't know really what this one does. There is nothing specific in this memory area, but yeah, I guess we can skip it for now. It's not going to be really important. So changing the screen to black and the border to black with the 0 values. Then poke 646,1, this sets the color of the cursor. Turn screen black, yeah, the comment actually says that. In this line, indeed, the screen is going to be cleared with the message, with the text of the game, with the name of the game, Wizard's Crown, and then poke 646 will change the cursor to line, not to line, it will change the color to 0. So this is black. From white it will go to black again. And the whole interesting thing actually happens at line 5. So there is variable $n, so it's a string, assigned, and this contains a value of w.pro.o. That's, I guess it's a file name. We don't see the file names here, but when I did a listing before, I've seen this file. So this one, there's a value of fi 40448, and also I see that the same value is used to call probably assembly program 40448. Yeah, that's the one. And then there is a go soup 20,000 in the meantime. So let's check this one first. So I have to go to line 20,000. Okay, what do we have here? So some comments, and then in line 20,010 there is a math involved. Z is equal to int, and there's a math fi divided by 256. So fi, the value of fi was 40448. So if I do 448 divided by 256, it's giving me 158, and this is a high value, I think, of the address. Let's see what is the value of 158. It's 9e. So this will be the high value in memory. Okay, this is the high value. So this will be used for setting this value somewhere. Where is this z? I see z here. And then, yeah, I see this one going to be used here, which is actually kind of funny because fi minus z, fi was exactly z was divided, so this is actually going to be reduced to 0. Fi is 40448, and then we know that and when we divide this value by 256, this will give us exactly this z value. So I think this is some kind of a trick used, I guess, just to blur it slightly. However, it's really easy to grasp it even without going into details that much. So in line 2010, I see this z int. So this is the one which we just described, and then poke 780, 781, and 782. So this actually is used to set the value of the register A, so of the accumulator. So this value will be set to 15. Then 781 is used to set the register of X value. This will be set to 8, and 782 gives the to 0. This is for Y register. So in 8-bit assembly, these three registers are used. So A, X, and Y is set, and then there's a call to sys call 65466. So what does it mean 65466? 65466. So this is FFBA, and FFBA, if you look at the kernel instructions, this is a set LFS. This sets the logical file, and indeed it takes A as the length of the file, so that was the value set to 15, and then this will contain the pointer. So the pointer X is the low value because it's a little endian, so a low value first in the X, which was 8, I think, and was it like that? 781, 8, and 255 for Y. I think this is correct. Let's see if I look at the correct values, because actually the this value happens a few times. Okay, no, so I was looking already in the wrong on the wrong line. That was here 158 and 0. So X, a low value will be 0 and high value will be 158, and as you already probably noticed, 158 is exactly the Z value we got before. So this actually will set the logical value at this location in memory. There's already something there actually, which is interesting. Okay, so now I can try just to see what's next. So that will be the logical file set, but it doesn't do anything yet here. It just sets the pointers to this logical file. Now this one, it's interesting, line 20. L is the length of the $n, that was the file which we have seen. So it actually gets the length of the file and do a loop to go through all the characters in this string. Yeah, it takes the one character at the time and does the ASCII value of it, and then it writes under the location 40447 plus L1, and L1 starts from 1. And as you see already, all these numbers, they are not really a random, because 40447 plus 1, because it starts from 1, this is exactly the area where we have this logical file. So this already writes this data there. So we can do AND over here, for example. Let's see, and let's run. And the cursor, as you remember, was changed to black, so I have to change it to white. Let's go to the monitor, or maybe I'll change it to blue, light blue, and let's see what is under area 9E00. So as you see, the program w.pro.o is there, written, and I think this gibberish is actually from my previous setup, because this values, this area should be empty, but as I have already loaded this game before, there is some gibberish. But you can imagine that there should be values of, I think, 0, or I think that's 0 over there. Anyways, doesn't matter, because we are about to find more. What do we need from this specific file? So in line 2030, after this end, I'm going to remove it. There is another poke, 780. So again, 780, 71, 782, already setting the A, X, and Y consecutively, these registers, and then calling 65469. 65. Okay, let's see this single line. And for me, it's always easier to also just check the kernel addresses, because that might be one, and that must be one, just by looking at the hex value. So FFBD, this is another one which sets the num. So this is set num. This sets the name of the file, which is going to be read from disk. And as I see in this line 2030, it sets the A register to L. So this is the length, so the how long the name is, and then 781 to 0. This is low byte, and 158 high byte. So again, it will point to this area 9E00. So this is what happens. And then what is the length of the end dollar, the string? I think I change the line, so now this is not going to, so the variable were removed. So I'll just do a quick end here, run. Yeah, that's the copy protection filer, but I can also do this, 7. Okay, that's the length. Yeah, I did end here, but actually the copy protection was indeed preventing me before. So the number of the length actually of the file will be set to 7 characters, and this is the set num from kernel. So like, this is very clear now. But why do we need to set LFS and set num? Normally, if you want to load the file, you need just to set the num, set num. So we only call this FFBD here from kernel. Okay. So the answer is that there's another, as you see in line 2040, there is another set of few registers, A to 0, X to, this is really funny, X to 0, because this value we already checked that it gives us 0, FI. Yeah, we need to run this. Maybe that's actually fun to run this. Okay, and now if you look at this with me, FY is 4 60448, and then Z is 158, and then multiplied by 256 is 4448. So in the end, this value is set to 0, as I said before, and then here, and then poke 782 is comma Z. So again, this is just the high byte, which is 9E, and then it's a call to 65493. 65493, and this is FFD5. And if you look into the kernel, this is to load or verify RAM from device. And in this case, we set the program set, not we. The program set 0 to the accumulator, which means that this will actually try to load. If this value would be different than 0, then it will try to verify the given file. And that's the reason why set LFS and set num is called before, because for this call, actually both needs to be set beforehand. So that's why the reasoning. So in this case, it will just do this call, and that's it. It just, that's my end. I will remove it. It just returns. So then after that, we are going back to line 5, where this goSoup call was done over here, line 20,000, and then there is sys40448 performed. Okay, so let's see what's in the memory here. Let's try to do end here. Run, okay. We have exited. Now let's go to monitor. And what you see here is the assembly program. So this is the program which was loaded from the file. And the first line already jumps to line 9E04. Line E03 is 0, is break. And this is the assembly program which was not here available before. It was just loaded now. So let's check what actually is happening here. So there is 3E7, and that's there is the value set, and there's a bunch of other kernel routines which we would need to check. So the list is quite extensive, as you see, but I guess once you know you have all the addresses next in front of you, it's just much easier. So FFE7, this is actually CLO, clear file table. It's called without any inputs, we don't need them. And this one calls also CLRCAgen, clear channel. So that's the one of the calls. Then this one goes to FFBD, which is already set num again, and it just sets the length of the file 3. There now it's a different order than we've seen in BASIC, but it doesn't matter. So the length of the file will be 3, and the pointers are going to 9F4A. 9F4A. Here we see two commands sent to the disk drive. The first one, IO, initializes the disk device. The second one is the block read command. It's good to have a look there, because 9F4D, because this also tells more than that. So here we see that the U1 command reads a block from a disk into the drive's buffer, and it reads from channel 2 from the drive number 0, that value is always 0 for 1541 drives. Then track 0 and sector, track 6 of course, and sector 01. So that sector will be read into disk buffer. So we are here, and after that there is another call to 9EF5. And 9EF5, this is already something which happens internally in this program. It writes the value under 9F58 and then also writes another values. It's a little bit of a spaghetti, of course. I think that the reason is that actually I don't know what is the reason, because I know how to already remove the whole thing in one go, so not sure why this code must be so sophisticated, to be honest. And then, for example, FFB1, this goes to listen for a device number. So device number is 8 in this case, so this is even hard-coded just to work from device number 8. So if we would try to boot this game from another disk, it's not going to work. And FF93, that's the sending the listen to the secondary address to serial bus. So the serial bus will be 6F in this case. And FF93 is called, and there is something put to the stack, the X register, and there is another thing that, yeah, I don't think this is really interesting to really try to understand. It would be nice to disassemble this maybe with some cross assembly just to see what everything here is happening. But this is just at the first look really funny to see that there's a lot of code over here, while this whole thing can be just easily removed from this copy protection, and I'm going to show you now how. So let's go out from this assembly and go to list to the line 5 where all that stuff happens. And I was just wondering, because I see that this could be already I could put this REM, the commenting out, over here, and this part of the code wouldn't be executed at all, and that would be fine. But still we have this operation of reading the disk and sending this read block command. So I think that's a little bit too much. We could speed it up for this, just to completely skip this copy protection, I guess. So I wonder if I could just do I need this FI actually later? Because if I even don't need to set this FI, then no, I don't need, because in line 9, that's the next line after line 5, this value is already changed to some different values. So I can already say here, even before, I guess, yes, and dollar is also used, indeed. So I guess I could just remove this line 5 or just REM it, so just to make it a nice, funny way of disabling this copy protection, but still keeping it as like a kind of preserving the original code, because it all fits in 80 characters, a single line, nicely. So with this saying, let's try to see if just by disabling line number 5 or commenting it out in this case, I can load the game and skip the copy protection. So yeah, the title already shown as it was clearing the screen and showing the text in white color, and this is it. There's no copy protection. Wizard's Crown version 1.0, designed by Paul Murray and Keith Brors. and I can play difficulty 1 to 5, where 1 is hard as far as I understand. And then there are a few things: sound, utilities, create disk for play. Let's try without the disk. Press space to play the game. So maybe somewhere in this game there is another check for copy protection, but I am not certain about it, to be honest. I think that would be it. So actually it looks like this is the only copy protection, and then that was the case for Shadow Spring, which I finished, and there was also only this kind of copy protection in which I just skipped in basic, and that was all. So it says you must use the create option before playing the game. Press any key to continue. Okay, so I guess I still need to create this disks. So I'm going to do step by step. First of all, I'm going to save this copy protection bypass to the file. And then I will make it as a separate file. So I'm going to disk options. Let's see. Let's read the directory of this disk. So this even really nicely shows you all the files. The boot is here, and 3 that's the disk name. It looks corrupted, but it's just a trick used to prevent the basic interpreter from displaying the disk directory. However, as you can see, all the files are listed nicely anyway, because Final Cartridge 3 easily bypasses these kinds of protection tricks. So first of all, let's try to change the disk name to, this will be Wizard's Crown. Okay. Do directory update. Okay, so Wizard's Crown, that's the new name of the disk. So I will just exit from here, go to basic. Yes. The thing is, I could have accomplished all of this much faster with modern tools, but that's not the point. It's fun to travel back in time to the end of the 80s. Names on the disk are still not visible, but this can be done by overwriting the area where the listing resides. We are going to skip it for now. I can load the boot, and I am going to go to this line. So I will just do rem here, and traditionally I'm going to call it BOOTHACK. Okay, let's see. Okay, so I saved the file, which bypasses the original check for copy protection. Let's see. So the directory, yeah, that's the one. This is my BOOTHACK, and I want to move this BOOTHACK up. Which I cannot do here. Sort. But I can do like this. BOOTHACK. Okay, and that should be the first file. BOOTHACK. Also the size is incorrect, but this is the hack of the listing, I guess. Write directory, yes please. So now it writes the new structure to the disk with my hack as the first file. So when I load with the asterisk, it will load the BOOTHACK. So let's go to basic. Okay. And when I try to load the program, it's indeed my BOOTHACK because this line is disabled. I still need to create this disk, so C. You will need 2 blank disks. Okay, I gotcha. For play, label them disk 1, disk 2. Do not remove any disk unless you are told to. Press any key to continue. So I don't have 2 separate disks on this SD2 ISC card, so I will just I had only 1, so I will just add 1 more disk because I see that 2 are needed, and I will continue briefly. Alright, so I have added another disk this way. I have to change it to disk 1, which is the third in on this SD2 ISC card. As you see, I don't use the physical disks just because it's just a little bit simpler, of course, to use SD card. So that's why I use SD2 IEC, which just emulates the disk drive. So I hope I'm not going to remove the other copy. Let's see. It works. I don't have an indication of which data disk is used, so I just have to count to 4. So now I have to change to, I'm on disk 3 kind of, and I have to go to game disk front, so disk 4 and starting from the start, disk 1. This should be it. And now the data will be copied between disk front and back, of course, and the disk I have provided. So this will take a lot of time actually, because I did it already with the original disk before. So I could probably also recreate it from there, but I want just to test everything just with this copy protection being removed. So that's some kind of like a test for everything. The good thing is that with this SD2EC and with final cartridge applied, I think the saving time is actually shorter. I'm pretty sure of it, because it took some time, and I see that here it's way faster. But still, as you see, there is a lot of swapping between these 2 disks. Maybe that's all. No, I think I have to do more than this. It just loads a chunk of data, I think, maybe of files, I am not certain about it, from the original disk, and it copies that to the save disk. So I think this is some sort of a way of trying not to stress the original disk too much, which is fair. Still, you need this original disk to boot the game, and of course it checks copy protection each time. Okay, now it asks for disk 2, and I was on the disk 1, so I will swap here. I hope this is the correct one. I hope this program also checks if the correct disk is inserted. So now going to the game disk back. Okay, and I think this will take another few minutes. Always a good time to clean your room a little bit to remove the dust. Patience is key. Alright, so this creation is a success. You are ready to play Wizard's Crown. Press any key to continue. So at this stage, I guess we are just going to stay with this play difficulty, but I'm going to read more about it later. And let's see, and for now, just if this stuff works. So insert game disk front. I guess that's the one. I don't know, to be honest, but the system will help me because I think it detects what disk is inserted. Okay. And now I have to insert the disk 1, which is my new freshly created disk. Oh, but there is a protection violation. So I see that it also checks this somewhere else. I'm going to hunt for another copy protection text or something that could potentially go wrong here. But yeah, that's clever, more clever than in Shard of Spring, as there is not a single place of failure or copy protection, but there is much more.